Hello everyone. I'm Ega Satvika Reddy, currently pursuing my first year of the BTech at Institute of Aeronautical Engineering in the branch of AIML. Today's topic is about relationship between lattice and basis. Introduction. Most solids have periodic arrangement of atoms. Crystals are defined by repeating structural units. Two essential components, lattice and basis. Structural periodicity determines physical properties. Use it in the metals, semiconductors, minerals, etc. What is a lattice? A lattice is an infinite periodic arrangement of points in 1D, 2D, or 3D. It is purely mathematical. The points do not represent atoms themselves. Key features are a lattice represents transitional symmetry of a crystal. Any point in the lattice is equivalent to any other point. Every point has the same environment. A lattice is a regular 3D array of the points. Represents mathematical framework of the crystal. Each point has identical surroundings. Points show where atoms can be located. Defined using primitive vectors like A, B, C, and the lattice parameters, length, and the angles, alpha, beta, and gamma. Only positional information, no atomic details are required. Lattice characteristics. It can be infinite in the theory, shows symmetry and periodicity of the structure, forms basis for the Bravais lattice, 14 types, 7 crystal systems, cubic, tetragonal, orthorhombic, heterogonal, trigonal, monoclinic, triclinic. Important for the identifying unit cell geometry. Helps calculate density, planes, directions. Mathematical definition. A lattice point R is defined as R is equals to N1 A1 plus N2 A2 plus N3 A3, where A1 comma A2 comma A3 is equals to primitive vectors and N1 comma N2 comma N3 is equals to integers. This means by representing primitive vectors in all the integer combinations, we generate the entire lattice. What is a basis? A basis is a set of atoms, molecules, or the group that is associated with each lattice point. Basis can contain one atom, simple structure like polonium, two atoms like NaCl diamond, etc. Many atoms, complex crystals. The basis defines the chemical nature of the crystal. Basis representation. If there are k atoms in the basis R1, R2, so on Rk, these are relative atomic positions within the unit cells. A set of atoms attached to each lattice point can be one, multiple, molecule, or ions. Defines the chemical composition of the structure. Combination of the atom position with lattice gives actual crystal. Basis atoms defines usually fractional coordination. Relation between lattice and basis. Crystal structure is equals to lattice plus basis. This means the lattice gives the periodic arrangement and the basis gives the actual atomic arrangement. Combining them gives the full crystal. Lattice gives repetition and basis give identity. Translation operation. Vector R is equals to n1 A vector plus n2 B vector plus n3 C vector. Applying basis to each lattice point, complete structure. Changes in the basis different crystals with the same lattice. Basis determines bonding structure, electron arrangement, mechanical behavior. Crystal system is less than crystal system is less than lattice system due to the presence of bases. If we contain bases, then it is great. For each lattice point R, attach the bases. Atomic position is equals to capital R plus small r1 for every basis atom I. This repetition constructs the entire crystal. For example, let us as we discussed right now, why lattice cannot be why lattice alone is not enough. If we only know the lattice, we only know where the points are. For example, FCC lattice can give NaCl diamond, zinc blend, CuAl, etc. What makes them different? Different bases. So, the basis determines the crystal identity, while the lattice gives the geometry. So, without bases, we cannot give crystal structures. Then, why bases alone is not enough? If you only know the bases, if you know the atom's local arrangement, but not how it represents in the space. Example, basis of the Cl at 0, 0, 0 and Na at 1 by 2, 1 by 2, 1 by 2 could generate many structure depending on which lattice it is attached to. So, basis needs a lattice to generate a crystal. So, if we observe, both need each other. Example for the simple cubic is polonium. Lattice is simple cubic. Basis is one atom per lattice point. Atom placed at 0, 0, 0. Effective atoms per unit cell is 1. Very low packing efficiency, similar to 52%. Example, polonium crystal structure. One of the simplest relationships. Lattice itself form crystal. Second example is NaCl structure, local rock salt, lattice type FCC, basis. Na at 0, 0, 0, Cl at 1 by 2, 1 by 2, 1 by 2. So, NaCl crystal is equals to FCC lattice decorated with a 2 atom basis. This reproduce the rock salt structure. Different atomic bases is a new structure. Na plus and Cl minus alternate forming strong ionic bonds, highly symmetry and dense packing. Common example of the lattice plus basis transformation. Then the third example is diamond structure, carbon. Parent lattice is FCC, basis 2 atoms per the lattice point. In the previous slide, we observed about NaCl, and now we are observing the structure of the diamond, which contains 2 atoms, has NaCl, but the position is different, 0, 0, 0 and 1 by 2, 1 by 4, 1 by 4, 1 by 4. Forms tetrahedral coordination, strong covalent bonding, high hardness. Same lattice has NaCl but different bases, different structure. Used in the semiconductors, silicon and germanium with some structure type. Also same lattice FCC differ bases, completely different structures. Graphical or the model interpretation. Think of it like lattice is equals to pins on a board placed at irregular distances. Basis is equals to shape attached to the each pin. If you attach A ball, simple cube crystal. Two balls, NaCl type crystal. A tetrahedral molecule, diamond type crystal. Changing the basis changes the entire crystal, even if the lattice is the same. Coming to the conclusion of the topic, lattice, framework of the points, basis, actual atoms that fills the lattice. Combination determines crystal geometry, atomic arrangement, physical and the chemical properties, helps understand classification of the structure FCC, BCC, SC, essential concepts in the material science and nanotechnology. A lattice gives the periodic arrangement and the symmetry of a crystal. A basis gives the group of the atom located around each lattice point. A crystal structure is formed by placing the bases at every lattice point. Mathematically, R is equals to, R plus R1. Different bases on the same lattice gives different crystal. Different bases taking on the same lattice gives different crystals, and same basis on the different lattice gives different periodic structures. Thank you.